Hello, I'm Andrey. I'm DevOps at Rakuten. In free time, I play with radare2, and today I want to show which tools this framework has. So, what is radare2? So first of all, it's open source. Not good. So it's open source. Hexadecimal editor and debugger, which is quite popular. You can see 16,000 stars, and it's open sourced because it's on GitHub. And there are frequent updates. So 5 hours ago, there was last fix. So historically, it was created as a forensic tool, but with time, it became debugger, disassembler, and a big framework for reverse engineering. In Radare book, we can read that Radare project is a set of small command line utilities that can be used together or independently. So, and today we will explore these utilities. There are a list of them. The main tool has the same name, radare2. It's hexadecimal editor and debugger. Another one is rahash to compute checksums of files, disk, devices, or strings. Rabin to extract information from binaries. Rasm, it's assembler and disassembler. Radiff, it's binary diffing utility, not for text files, but for binary files. Rafind is to find bytes in files. Rarun is for running programs. It's useful when you solve some CTF tasks. And rax is some mathematical expression evaluator. So there will be, if you don't have installed Radare, most likely you don't, there will be access to lab server. You can SSH and follow steps which I will show on my screen. Or if you have, by any chance, I think no one of you have it installed, you just need to clone this repo with just few files. But it's not needed. You can use any file to experiment with. So let's explore first tool, radare2, the main tool, as a hexadecimal editor. So what we will do, we will modify any file in hex, and we will do some search in hex, and we will debug programs step by step in debugger, like in GDB or some other debugger. So to modify a file in hex, very basic task. There are many hexadecimal editors which can do it. You need to open a file. If you SSH to lab, let me go and see. There are 2 people SSH'd. So if you have laptop, feel free. Where is it? So go to this folder. You will find file edit.me in hex. If you run file utility against this file, the utility will tell you that it's just a data, so it cannot recognize what kind of file it is. Let's try and check. First of all, yeah, so in my case, it says that it's just a data, so it cannot recognize. Let's fix this file in Radare. So, oh, sorry. Also, there is a warning, be careful. All changes automatically will be saved by default. If you want to disable it, you need to set up it. So let's open it with -w. It stands for writing, and you need to provide file name. Then enter to visual mode by pressing big V, and you will see something like this. It's just a usual hexadecimal view, as you can see on my screen. So there are few commands which is useful, which you have to know. To enter cursor mode, you need to press small c. You will see cursor, and you can move by H, J, K, L buttons. It's the same as in Vim. You can jump between hexadecimal view and between ASCII view by tab. And then we can go to insert mode by pressing I, small I, and change. So again, be careful, all changes will be saved automatically, so there is no undo. So let's enter cursor mode, change to ASCII view, and we need to change this ext to PNG. I just made it broken, PNG. Then press few times escape, so editor mode will disappear. And then we need to quit radare and run file command to check what this file is. Quit by Q. So currently we just changed header of PNG file from broken one to correct one to PNG, and this can be recognized as PNG image. The image is here, it's from radar book. It shows you radar learning curve, so difficulty will increase. Difficulty will increase, but if you want to do anything useful, you need to learn all these commands. We just did some very basic thing. Let's search in hex. How to search in hex? We need to open the same file or any other file in radare. This time we don't need to provide -w. We don't want to modify it. We just want to explore it, and go to visual mode again by big V. So we will see the same view. To search, you need to enter to command mode by colon. It's the same as in Vim, and use slash command to search. By the way, if you add a question mark after any command, you can get a help. So let's do it. So we entering command mode by colon, and then we enter slash and question mark, and we can read documentation about this command. We need /x to search for bytes. You can search for a lot of things. You can search for strings, but we need just a byte. Let's search for byte 42. So you will see that there are 56 bytes with value 42 in this file. Then come back to visual mode. You can hit enter or enter V. So you just press enter. You will see these hits. It will highlight you the line where byte 42 is located. So it's not so useful because you still need to search by your eyes where this byte is. But there is, in visual mode, there is a highlight command. It's also slash. You just press slash, also enter 42, and you will see highlights. You can move between, the same as in Vim, you can move to next or previous hit by small n or big N. Let's move. So next, 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 or back, big N. So this is basic search in radare. It's very useful if you want to search something in any file, binary or text file. So if you want to remove highlights, just make empty highlight. Yeah, to make hits more visible, we need to use highlight in visual mode. Also to move, also the same as in Vim, to move to the beginning of file GG, to move to end of file G and big G. Let's do it. you need to, okay, just press G and G. You will be at the beginning, you can see offset 0, 0, and at the end G and big G. You can move to the beginning or to the end of file. So currently we move to the end by G and big G. So here is the end. We can see that there is nothing else. So next use case of the main tool is as a debugger. So it will be the same as GDB. This time let's debug bin_ls. You need to open it with -D option, and you will see this screen. Probably it's not visible. On the screen you can see disassembly from the left side. From the right side you will see stack and registers. Let's do it. So first of all we need to quit Q in visual mode, then enter Q once more, and you will exit. Let's start debugging of bin_ls. And small v, not big V, but small v. Small v will bring you to this panels mode. Very useful command is dcu. D stands for debug, C for continue, U for until. Until, and you can say some address, or you can specify main function. Let's continue execution until main function. This is just a help, so let's enter to command mode by press colon, dcu and question mark. You will read help, and then dcu until main. So we are at main function, so you can see that hit breakpoint at this, and enter to come back. So you can see main and some prologue of main function. So again, to enter command mode, you need to press colon. To exit command mode, just hit enter, the same as Vim. So after executing dcu main command, you will be at this point. You can move step by step by pressing small s or big S to step over function. So if you don't want to go inside function, you just can execute whole function. The same as most other debuggers. So it must be nothing special. You can set breakpoint by command db and specify address. Let's do it. So let's execute few steps by small s. And then let's set breakpoint at this address. So you can run command db just to see your breakpoints. We can see that we have one breakpoint. You can continue execution until breakpoint, so DC is just continue execution. By the way, you can execute program forward and backward, so you can ask radare to move step by step as usual execution, and you can rewind it back. This is a nice feature. I never used it, but there is such feature. So let's run DC. So we at the function, you can see that we came to the breakpoint. Very basic thing. Also, we can modify registers. There is a command dir, D stands for debug, R for registers. You can see value of register, or you can change register. Let's change ESI, because ESI was set to 2F, so we know its value. Let's confirm it is. Yes, it's correct. And then let's change it to something. I don't know, 1, 2, 3. So it's changed to 1, 2, 3. Just to verify, yes. 1, 2, 3 in hex must be 7B. Okay, next. You can reload program. For example, if we change some registers, we made some changes, and obviously program will crash. Not obviously, but most likely. And we want to reload program and start it from beginning. Just run command OD. It will reload. there is some error because our radare is too fresh. I installed it from GitHub. It's not stable version, but actually it does the thing. So if you check, you will be at the beginning, and if you run DC, you will come to breakpoint to this function again. So just ignore the error. It does what it should do. You can check breakpoints and remove them by command db minus. So to set breakpoint, you need to run command db. To remove it, db minus. Let's do it. So breakpoints are still here, and let's remove this one. And run command db to confirm there is no any breakpoint. So b is disappeared. And there is command dcr, useful if you inside some function and you want to run it until red, until end, and check your stack if there is stack overflow or something. You can do dcr. Command stands for D for debug, continue until red. So dcr is continue until red, step over until red instruction. So let's run it. We can see that our binls made its work, so it's just printed out list of files, but radar crashed a little bit. That's so let's q to queued panels mode and enter command q to queued radar. Panels mode and q radar. Okay, so that's how we can use it as a hexadecimal editor and debugger. So what we did, we modified file in hex, very basic thing. You can use any other tools, but this tool is console based, so you can do it on any server. You can search in hex. You can use some advanced search or simple search, and you can debug program. I showed you just very basic debugging session, but it can do a lot of debugging tricks. Next tool is rahash. It's block-based hashing utility. What we will do, we will calculate hashes of string or file. Maybe too small. So to calculate multiple hashes for a string, you can use, actually there are also many online tools to do this, or even in standard Linux there is MD5 SHA-256 utility, but rahash has much more. It has 61 algorithms, including some encryption and decryption from base 64 and finishing some serpent ECB, I don't know what is it. So you can run command rahash and say all to calculate all hashes. Let's do it. Rahash algorithm all, and we will specify string hello world. So it will calculate all hashes for this string MD5 SHA and blah blah blah. Sometimes it's useful. What you can do, you can calculate hash from offset A to offset B. For example, you have a file, and inside this file you have a string just in between, and you want to calculate exactly this part. You don't want to calculate hash of whole file, you just want some part of this file. Let's do it. So let's create file first. So the MD5 from hello world is this one, and if you run this command from starting from third byte and ending to byte E, it must give us the same value. Yeah, value is the same. So from this byte to this byte, there must be a string which is very similar to hello world. What you can do, you can hash big files by hashing each block. So this is from radar book, and later determined what part of it has been modified. It's useful for file system analysis. Let's do it for our disk. We have VDB. Just a second. VDA. Yeah, we have disk VDA. It has 3 partitions, and let's calculate hash. Probably, if you don't have root access, you cannot do it because only root can do it. And let's calculate hash with block size. You can specify any block size, and you can say print by blocks, and then specify device. So we will use EFI device, this one. And because it's too big, we just print 20, or let's print just 10. So you can see that this device you can hash by some parts, and you can see that at the beginning it has some data, but after that it has probably just zeros. So it's useful to inspect big files or inspect big disks. Summary or summary. What we did, we calculated some hashes of string or of file or of device. It has much more options you can explore by yourself. Next tool is Rabin. It's binary program info extractor, so we can extract some binary information from ELF files. What we will do, we show some binary info. The same. So yeah, on this screen you can see Rabin with big I flag. It will show you general information about binary. It will show you which architecture is used. It will show you either canaries. It will show you interpreter, which you can change. It will show you an X bit. If there is independent execution or ASLR. All the things you can get from Rabin. There are also alternative tools like pound tools which can do the same, but radar also can do this. What else? You can extract a lot of things. You can extract, I don't know, is it visible or not? Probably it's not visible. You can extract some sections, segments, some strings from raw data. Let's extract it. So from this section you will extract all strings, not from whole binary, but just from this section. What else? It can show you entry point. It can show you, also it can print these things in JSON. So it's good for automation. So you can get all this data in JSON. So it's the same as read ELF utility, or I don't know, some other tools like this, but more advanced. What we did? Nothing. Keep sleeping. RASM, assembler and disassembler. What we will do, we will translate from assembler to bytes and translate from bytes to assembler. RASM has 68 ASM plugins. You can check by big L, double L, for many architectures. So it's very simple tool. You can assemble instruction NOP for x86 or for WASM WebAssembly or for BrainFuck, and you will see opcodes of them. Or you can do vice versa. You can disassemble from bytes into assembly for x86, for WebAssembly, the same bytes, or for brainfuck. It understands some directives, probably it's not visible. So you can write some shell codes. You can write some big programs in assembly and then assemble it. What we did, some basic assembly and disassembly. Radif, what we will do, we will compute Levenshtein edit distance and compare true with false. Radif has also a lot of options. So let's create two files, hello world and age below world. And by radif -s you can calculate edit distance between two files. It can be any file, not only text file, but also binary files. So it can show you similarity and distance. For the same files, Levenshtein distance will be just 1 and similarity will be the same. Also, you can compare bin true with bin false. There is such utilities in such way as in hexadecimal representation. Sometimes it's very useful to understand what changed in files. Also, you can do diffing with analyzing binaries. So if you provide A for analyze and C, I don't know for what, then it will tell you which function has differences. For example, entry is totally the same, but main function is a little bit different, and there is some function with name 18C0 also has some differences. So you can understand where exactly these binaries are different. Also, it can do some visual graph diffing. I just made screenshot. I never done it. You need to use x.tool to show it, but it's quite useful, I think. So what we did, we computed Levenshtein edit distance. We compared it true with false. Obviously, it was different. Find byte patterns in file. What we will do, we find some bytes in file. Very easy task. Find has also many options. For example, in bin ls, we can find string LA or whatever string you want to search. It will give you a list of offsets where the string is located. So if you enter to radare and go to this offset and print string, P stands for print, S for string, you will see that actually there is such string with LA, long info or lackware version. Probably there is something else. So let's do it. It's very easy to do. So find. Or we can search, I don't know, for string C0. Oh, C0 has few strings. R2 bin ls and S for seek to this offset and PS. So we can see that there is some string starting with CO and some, I don't know what is it. And let's see what is here. Yeah, there is also some garbage. But you can search for strings, or as you can see for hex, there are many options. Also, you can detect file types using signatures. It's the same as file utility, but sometimes you can find files, it's so-called polyglot files, which at the same time as P executable and zip archive, or it can be PDF, zip, and JPEG file. With -m option, it can check all signatures and tell you what kind of file it is. The same tool, binvolk, there is the same tool, binvolk, which you can use, but everything is inside Radare framework. So what we did, we found some bytes in file. Run. What we will do, we just skip it. Okay, let's check at least help. So it has a very small help. It just has examples how to use it. Usually I use setenv if I run some binary to change environment, or I change stdout or input, or sometimes I do preload of some libraries. It's useful for CTF tasks. RAX, it's radare-based converter. What we will do, we convert data from one representation to another. So it also has a lot of options. Basically, it converts from int to hex, from hex to int, and so forth. For example, you can convert string kukurukon to C byte array. It will look like this. Or you can convert string kukurukon to just bytes, or you can convert it to bytes and then convert it to random arts. Maybe you can see it when you generate some certificates for SSH, some key pairs. Other tools, there are also rav-c2, ravsign, and rag, but I have no idea why it's needed, so I never use them. So the framework is very big. I just showed you very basic usage of these tools. Okay, thank you for listening. That's it. Questions are accepted, yes.
Can I use, you mentioned the second tool, which is the...
Okay, let me give you the microphone.
Yeah.
Just a second. Okay, we have 7 minutes for the questions, so please.
So the tool that you mentioned, like the second one to analyze ls comment.
The main tool, Radare.
Is it like advanced enough for me to run my game, connect to the process, find my HP in memory, and then increase it, like as a player?
Yes, you can connect to your program and you can modify anything in your program if you have rights.
But can I actually, like, is it advanced enough for me to really, like, analyze? So I'm playing the game, I have a character, I have one, like, I'm dying. And so I want to find my character and with, like, with certain patterns, find it and increase it?
Yes, exactly. It's what we do in CTF once a month.
Cool, thanks.
Okay.
Thank you for the questions. Any other questions? Okay.
Okay, so my question is, can I use it to analyze some managed languages like C#, Java, and so on?
Yes, this tool has decompiler, so not only disassembler, but also decompiler. You can decompile it to C, and I think, I'm not sure about Java, C# or other languages, but C for sure.
Okay, thanks.
Okay, any more questions? Anyone else? Okay. So, yeah, if there's no questions, we can finish our presentation and get back to the break.
Okay, thank you.